In this video, we'll be learning how to use factoring to solve quadratic equations. So the zero product property tells us that anytime you multiply things together, if your solution or your answer is 0, that means that either the first thing that you multiplied or the second or both are equal to 0. So what this tells us is if you have two factors and their products equal to 0, you can take each individual factor and set it equal to 0 to solve, because either the first factor has to equal 0 or the second or both for that equation to be true. So when you're using the factoring method, just to summarize, like before, you want to make sure your equation is equal to 0. Then you can factor what you see in your equation using one of the methods we learned. Once you have your factors, you're going to set each individual factor equal to 0, and then you'll have two equations that you can solve for x, because remember, quadratics can have up to 2 solutions. So let's go ahead and look at some problems that we can do using this method. Now, we did learn how to do these using graphing, but factoring is faster if you're doing it by hand. So again, you want to make sure it equals 0. After that, you're going to start factoring. When you factor, always check for a greatest common factor first. No matter what type of problem it is, check if there's a GCF that you can remove. So here we look at number 1. Right away, I notice this one's not equal to 0. So I need to move that negative 31 to the other side. And when I move it, it changes to plus 31. Here I'm going to combine like terms, so I can actually combine the 2 and the 31 together. Now that I have my equation equal to 0, I can factor it. I notice this one's a trinomial. So since it's a trinomial, I'm going to set up my parentheses, and I'm going to put x in each one. Then I'm going to try to come up with numbers that multiply to give me that 33. So blank times blank equals 33, and blank plus blank equals 14. So for 33, we could do 1 and 33, or 3 and 11. So here we're going to be using 3 and 11. So I'm going to put a positive 3 and a positive 11. And don't forget, this is an equation, so at the end it should say equals 0. So your factors are on the left, but you should still have that equals 0 on the right. And now we can use this to solve the equation. So what I'm going to do is I'm going to take each individual factor now and set them equal to 0 to solve. So here I'm going to have x plus 3 equals 0. Here I'm going to have x plus 11 equals 0. And I'm going to solve those for x. So my two solutions are negative 3 and negative 11. If we were to have used the graphing method, these would be the x-intercepts, or the zeros on the graph. I'm just going to write my final answer in a solution set. So if you write in a solution set, you just put those answers together. So here, x would be either negative 3 or negative 11. I like to go from lowest to highest, so negative 11 and negative 3. As long as you have those two answers somewhere, your solutions are correct. Here in question 2, my equation is not equal to 0, so I need to move those to the left. So it's going to become 3x squared plus 29x minus 10. So remember, when you move things, they change signs. Now that my equation is equal to 0, I can start using factoring. Always check for a GCF first. So if I look at 329 and 10, the only number that those can be divided by is 1. So I don't have a greatest common factor there, so I'm going to start to set up my parentheses. This time, since it begins with 3x squared, I'm going to put a 3x and a 3x in those parentheses. And now I'm going to make my list of numbers, so I'm going to do my blanks. So here I would have blank times blank equals, I'm going to do it up here. And blank plus blank equals 3 times negative 10 is going to be negative 30. So that top blank gets negative 30. And then the bottom blank gets the 29. So I'm going to make a list of numbers that I can multiply to get 30 here. 1 and 30, 2 and 15, 3 and 10, 6 and 5. If I wanted to get 29, I would use 1 and 30. And since I have to subtract them, they're going to be different signs. Remember, the bigger number matches your b. So 30 is going to be positive like b, so the 1 is going to be negative. So I have negative 1 and positive 30. I'm going to go ahead and put those inside my parentheses. And then remember, with these, you want to check at the end if you can divide by a greatest common factor. So in my first parentheses, the only thing I can divide 3 and 1 by is 1. So that stays the same, 3x minus 1. In our second parentheses, I can divide 3x and 30 by 3. So that's actually going to simplify to x plus 10. So my factors are 3x minus 1 and x plus 10. Now that I've factored my equation, I'm going to set each of those factors equal to 0 and solve for x. So I have 3x minus 1 equals 0 and x plus 10 equals 0. And we can solve those for x. So for my solutions here, I get 1/3 and negative 10. And I'm just going to write it as a solution set. So my lower one's negative 10. My higher one's 1/3. Our next one looks similar, so I'm going to set it equal to 0 first. Right now it equals 80, so I need to move that over. So I have 4x squared minus 32x minus 80 equals 0. Remember, before you do anything, check if there's a greatest common factor that you can factor out. So here, all these numbers can actually be divided by 4, so I can actually factor out a 4. And I'm going to work backwards to see what would go in that parentheses. So I would get x squared minus 8x minus 20. So it's the same equation, I just factored out that 4. Now we can factor the trinomial that's in the inside. Since this starts with x squared, I can put x and x. And I'm going to put my blanks. Blank times blank equals negative 20. Blank plus blank equals negative 8. So I'll be making a list of numbers that multiplies to 20. If I want to get 8, I would have to use 2 and 10. And since we're subtracting, they're going to be opposite signs. Since my b is negative, my bigger number is going to be negative. So I have a positive 2 and a negative 10. This one we don't have to divide by GCF on this step because this one started with x squared on the inside of this parentheses. So now I can set each factor equal to 0 to solve. So I'm going to set x plus 2 equal to 0 and x minus 10 equal to 0. So my solutions are negative 2 and 10. And I'm going to go ahead and write that in a solution set. So just to summarize again, look for GCF first because that might make your problem a little bit easier. If we had started and did 4 times 80, we'd get 320. That would be really hard to work with. On problem 4, I'm going to set it equal to 0. So I need to move that negative 25x over. So it becomes plus 25x equals 0. Now, this one's a binomial, not a trinomial, so it's going to be a little bit easier to factor. But I am going to look for GCF first. So here, if I look at 20 and 25, those can both be divided by 5. So I'm going to factor out a 5. And then they both have an x, so I can also factor out an x from there. And then remember, you just work backwards to see what would go in your parentheses. So 20x squared divided by 5x will be 4x. And 25x divided by 5x will be 5, because here my x's cancel. So these are my two factors, 5x and 4x plus 5. Here we would want to set each one equal to 0. So I'm going to set 5x equal to 0 and 4x plus 5 equal to 0. And I can solve each one for x. Here I would just divide 5, so my x is equal to 0. Here I get negative 5/4. So if I write that in a solution set, I have negative 5/4 and 0. So here, even though this one didn't have parentheses, it was one of my factors. So I had to set that one equal to 0, 2. If you look back at problem 3, I didn't have to set the 4 equal to 0 because 4 cannot equal 0. So that wouldn't make sense. You're only doing the parts that you factored that have variables in them. So let's go ahead and look at our last example here. I'm going to start by setting this equal to 0. Now I notice this is a binomial, so I'm going to look for greatest common factor. But for 9 and 64, those both can only be divided by 1. That's the only factor they have in common. So the other method we learned was to look for a difference of squares. So here, 9x squared, they're actually squaring 3x. Because 3 times 3 is 9, 3x times 3x, 9x squared. And then 64 is actually 8 squared. So here they have a difference of 2 squares. They're squaring 3x and 8 squared. Remember, if they have a difference of squares, you can put those together in two factors, but one of them is going to be plus and one of them is minus. So my first one will be 3x plus 8. The second one will be 3x minus 8. Now that I have my two factors, I can set them equal to 0 and solve for x. So here I'm getting negative 8/3 and positive 8/3 as my solutions. And I'm just going to put those in a solution set. So this is factoring or solving quadratic equations using the factoring method. Remember, you want to make sure your equation equals 0 first. There's a lot of ways we learn to factor. So always look and check if you see a greatest common factor, because if you do, you're going to want to take that out first. If it's a trinomial, you can use the method with the blanks. Blank times blank, blank plus blank. If it's a binomial, check for a greatest common factor. If that doesn't work, look for a difference of squares.